move on to the next set, and next out of the box is another UK made set, the EMS Mercury 1040. We've covered this before. We've got no circuit, we've got no information other than an original sales thing. Electromedical supplies are more likely to have done things like electroconvulsive therapy equipment. Again, we've ended up with these side things which are so easy for me to lose. So I'm taking those out on video to remind myself when I edit it that I need to go back with the set. I think we're going to have to improve that. That's, I don't like insulating tape splicers. Could say the wire's a bit thin, to be honest. We'll see what the voltage drop is. At the end of the day, it's only got to supply about 1.5 amps, hasn't it, on transmit? So do we power it up without opening it up? I did try another microphone on that Magpie AutoScan 5000, and Mr. Chippie said our microphone sounded a little bit better than the customer's microphone. We've got a factory original one attached to our sample Magpie AutoScan. So we haven't got a mic with this. Does our piece of paper tell us what mic to use? Mercury is not on our list. So we'll try it with standard replacement mic, Cybernet wiring, and that'll be it. Right, power supply is on, powered up, it's on channel 15. A lot of these came with some daft selective calling thing, which there's not a lot you can do with it because you know, without knowing the parameters. So at least this is the standard version. It seems to have got an extra hole there. Here's the sales blurb. Basic version £109 plus VAT. No. So if you've got the cat call selective calling system, it's under the 1 and the 4 there. So no idea what that is. So I think the thing to do here is to use a standard replacement mic, the Cybernet one, and we'll go into PA. I did one of these before about 10 years ago, so and that's the only other one we've ever seen. So go into the PA jack at the back, switch to PA. I've got an avalanche of things coming towards me, usually via the microphones. Right, well that made a click out of the speaker, so that's good news.
Testing 1 2, testing 1 2.
Right, well I think we're in business there.
Testing 1 2.
Do we have
Control over that? We do have control. No, we don't have control.
We do, don't, we don't. It's always the same volume. Right. don't know why I'm getting feedback. Are we? Ah. Oh, aren't you supposed to have the PA speaker plugged in? Does it work without a mic? Not sure what's happening there. I'll just see if I can do some research, because on the face of it that seems to be the right mic, but then secondly we seem to be getting feedback. Or is that just because there's a fault on the set? How can it do that? Let's go back in. Weird. I don't know whether this is extreme microphony, because it can't be the microphone, because there can't be on the way the CB mics are wired. There's no the insert isn't connected up when you're not in receive. Sorry, when you're in receive. So if you're not in transmit, the mic's not live. I'll just turn the thing off. It could be extreme microphony. Better not lose these screws. I mean, in business radios, this kind of racket would be a loose VCO can. Oh, that's the wrong side. So it's had sticky pads, and it makes you wonder whether it had some cell call thing. So we'll take the other lid off. So again, it uses a general, it's a bit like a DNT, it uses a general, I was moaning about that team base station which uses a general purpose IC, and then it uses crystal mixers to do transmit and receive separately as far as the frequency works. So they are a FAFTA setup. Right, let's put the power back on. With the lid off, it's even worse, isn't it? We're actually screwing up the earth to the mic. We seem to have lost that. But if you've got microphony, normally the VCO is going to be in an enclosed can, and it isn't on these. So, as it happens, I mean, I can't see anything there. I'll tell you what, we're going to receive first. We normally do transmit. So I'll just put 2779125 on the signal generator. Comes out of both speakers, how bizarre. It's atrocious receive sensitivity. Or have I got the RF gain down? No, I haven't. Do we need an extra earth? Let's have a look. Nope. Well, I'll tell you what. We'll fill in our sheet. Right, well, I'll put picture in picture on, and then you can see what I'm seeing. Can't get 12 dB SINAD. Can get 10. I can get for 2 microvolts. No, it's not. It's 6.4 microvolts. I can't get 12 or 20. We can hear it. Down to about 0.8 of a microvolt. So I'm hoping it's either IF or something like that. So squelch is going to probably be affected. Put squelch on. Never opens. And then we'll do the opposite sensitivity of squelch. It's 10 microvolts. Let's see whether we can tilt it up for you. Meter. No meter indication. Right, let's go to transmit. Looks like we've got to unplug the extension speaker. Right, let's go over to the appropriate meter. Go to the 3 watt scale. We're on full power on the radio. It's doing 2.5 watts. Bit like a new set then, isn't it? And on, at least it's got a real channel selector switch. Channel 40. That's 2 watts. You get that every time you transmit. And on channel 1, 2.6 watts. Hopefully it doesn't do that with the case on. Low power on channel 20. I'm still going to do it again. It's 300 milliwatts. And on full power, the consumption is 1.33 amps. Deviation. Can we get a deviation with it doing that?
1 2 1 2 1.
Why is it coming through on receive? Why isn't it muting?
1.
If that's the case, then the deviation is 4.5, which could be a good reason for it to come through. I'll put 4.5. I'm just tempted to just plug it into the other test set right now. See what the deviation really is.
1.
It's about 3, isn't it? I could understand it if it was 30 or something like that, but it isn't. Oh, this is so frustrating. It's where to start. Is it some decoupling problem? You know, why isn't the speaker muting on transmit? Why is the speaker on all the time anyway? What's been here? Because whatever it is, it's stopping us from seeing the printed circuit board. These things can become hygroscopic, as we often see, and then you've got problems. The circuit board hasn't been cleaned at factory level. I think we'll start by, we'll see if we can just remove this, or whether we're going to have to get chemical cleaner on it. Yeah, I think we're going to have to get the chemical cleaner on this. We're probably going to end up having to clean the printed circuit board so we can see that we can actually look for dry joints. See, there's quite some corrosion on these potentiometers. So you think it's been in a damp environment. But of course, it was in a van for 20 years, mounted on the dashboard. Of course, it's going to be damp. I'd rather not have to go and get ours out of storage, because that would be costly. Okay, so the good news, I've disconnected the internal speaker. I found out that the extension speaker sockets had been shorted out, so it didn't mute the speaker. Perhaps the socket's faulty, but we can cross that bridge if we can get the rest of the set to work. I've gone over the board for dry joints to some extent, and lo and behold, we now have the meter working, having got rid of those sticky pads. So that's progress just by removing the sticky pads and cleaning the board. So I'll just see if we can get something extra on transmit. I'm going to have to probably look at my previous video to see what conclusions I came to. I never expected to see another one. You know, I set out to do these videos to demonstrate one radio. So, you know, each of the 200 and something UK FM CB sets under the 2781, the plan was to go through them, do one video, and that was it. Not continuous videos, but it doesn't matter how many radios you do of the same type, people still want to watch them, and they are all different, and I can accept that. So, where were we? We're going over to the main meter. That's there. That's definitely on the inset picture. So we'll go through the transmitter. Remember, we've got no circuit diagram. We'll have to go through the frequency side of things. Right now it is 2779073. So that does need pulling up, but not at this stage. We've got to get the 10.24 right first. $27,79073. So cleaning PCB restored meter. That sticky pad was really good, as in sticky, but across all those contacts, you know. So I am looking here, we're going to be having, we're not going to touch the VCO, which will be there. This will be the 10.24 trimmer. One of these will be receive, one will be transmit. We've got the trimmers there for that. That's probably the injection. I think that's probably going to be received, because that could be, well, the injection to the IF from the receive side. Then we're going to be having probably that or both the detector, and that's the FM chip, and then we've got intermediate frequencies going to be there, and presumably these are going to be the front end. So that's kind of my guesstimate. And then here, this is probably the fundamental from the synthesizer. That's probably used as a doubler, and then again to generate the frequency. So I think we'll start here and then we'll work backwards. And let's hope none are broken. That is too tight for me to move. I'm not going to... I can see we're going to have to get a hairdryer on these. I'm not going to get the soldering iron down them. Right, start here then. I've got to look back at our video to make sure that this one's not supposed to have a core. That's too tight. It's been in a very, very damp environment, this. We're going to have to, I'll have to come back to this. I'll come back to this after lunch and we'll get a hairdryer. I'll tell you what, we'll have a look at receive, but we'll see whether it's anywhere near frequency. So I'll get the oscilloscope out, and we'll just look at where the 10.24 is. Wrong button. Is it between 3 and 4 if I get the DNT manual out? So here's the circuit for the DNT. And it's between pins 3 and pin 4 is the crystal. It's the same synthesizer, the Motorola MC145106 or 109 or whatever it is, whatever. So it's going to be between pin 3 and 4. So looks like they've provided a test point 10.2389, so it's slightly low. So if I can just put that prod on an earth, and then we'll twaggle that. That's so tight it's going to break my ceramic tool. So I'm going to have to start it off with a screwdriver just to kind of break the seal, so to speak. Do you know, let's put it back exactly where it was. So that looks to be as near as we're going to get to 390. See how that's affected transmit. 79099 has brought that up. So I think that's going to be the transmit one. So that's done with the oscilloscope. Again, that's too tight for me to use the correct tool with. So we'll use the incorrect tool initially. I'm going to have to prove that that's receive, because I'm not getting the kind of variation I want. I can't get it on frequency. It's not stupidly off frequency, not noticeably off frequency, certainly not illegally off frequency, but it would be nice if we could just put it up that little bit more. So we'll just check with here that I'm doing the right one. So that we're looking for that musical note. And we're looking to nullify it with injecting 10.695 loosely. And so I think it's going to be this one. But it isn't, is it? It's that one. That's a conundrum now, isn't it? So that is the transmit one. It isn't, you know. Everything's affecting everything. This is bonkers. Get that as high as we can. Right, it's got that as high as we can. So that's on frequency. Check the signal generator. As low as that will go. So it seems that's the receive one, which I didn't expect at all. So I've now altered the 10.24 again. Let's see where we're on transmit. Just put you with the... I don't like all this having to make a compromise, but what else can you do? So if that is transmit, yeah, we've now lowered it to the correct frequency. They're interactive, folks. That's supposed to be transmit, but they're interactive. That's spot on frequency on receive. Let's see whether we can get transmit. So it's far too high now. So that's transmit now correct. And that's receive now correct. But it might have thrown the IF slightly out. See where this receive is. So that's corrected receive. Well, got it nearer. Where are we on transmit? What a game. Now, see whether we can get transmit. Sorry, receive. That's as low as that's going to go. That's receive now spot on. Back to transmit. Just can't get that as low as I want it. There we are. Spot on receive, spot on transmit. Wow, what a faff. We'll go back to putting the test equipment speaker back in. And straight away we've got SINAD of 12 dB for 2.4 microvolts. For 10 dB, sorry, 10, .1, and it'll do 20 for 10 dB, for 10 microvolts. So we're definitely getting there. So I wonder if doing the detector, I suppose we're having dinner, but this is exciting. Let's put the oscilloscope on. It's going to be with that or that. They've gone and filled these with wax, haven't they? Can't shift it. would be that one. I'm going to have to get the hairdryer on this. So I'll leave it on, go and have lunch, and come back with a hairdryer. Okay, well, I'll take picture in picture off. I just want to backtrack. Over lunch, I watched my 2017 video on this, and I've been telling you all wrong. You have got to the right result, but I want to know what the 10.24 is. So it turns out, I'm thinking that's 10.24, and it isn't. That's 10.24. Transmit, receive. But they are interactive, and this is what the problem was last time. And last time, with a lot of care, we managed to get 3 watts out of one of these. And with a lot of care, we managed to get a just about undistorted signal. So, just want to see what the 10.24 is. .2389. Well, it's not stupidly wrong. Right, I was going to go and get a hairdryer. I don't think we've got one. What I did do is I took a screenshot from the video. So we've got transmit meter, receive meter, deviation. So receive 10.24, transmit, IF symmetry and detector. So we didn't go lower down the alignment than that coil, and I'm not surprised. I didn't have the sticky coils though, and I don't want to use the soldering iron on that polythene one for a start. So I'll just go and get, we've got a heat gun. I'll be careful. I'll put my hand there, so if I can stand it, the radio can stand it. Let's go back to transmit. Picture in picture back on. Unplugs extension speaker. Right, let's get the, is it the blue one for these? It would be if they moved. Let's go back to the heat gun. I think the point is it had wax in them. We're now at 3 watts, and that's what we managed out of the other set. What I'd like to find is an Allen key just to shift those coils. You'd never adjust them with an Allen key. I'm gonna have to get up and move things. So once again we'll do this with the receive. We'll see the wax melting. I definitely saw the wax move then. So let's see if we can do the detector. Better plug the speaker back in, hadn't we? And change to the oscilloscope. I think we've got better symmetry on this than the other. Wow. That's better. We'll do that on the SINAD meter. Do that on the SINAD meter. So I'm kind of looking at both. I don't know whether to show you the oscilloscope or the SINAD meter. Let's go to SINAD and see what we can see. Go back to 12 dB. I'll have to give that some heat. See if we can do something with the front end now. Still as deaf as a post. I didn't give a SINAD meter reading last time, so perhaps we weren't doing it then. We'll just do this, which is injection, I think. I bet these are quite good for bleed over because it's as deaf as a post. You know, so was the other one. We're nowhere near where we normally would be. It's 1.6 microvolts for 12 dB SINAD. For 10 dB, 1.2. .8. It's about like that. No, it's not as bad as one of those Cobra-looking Cobras, 29, whatever it was, which looks like a Cobra, with all the digital displays. It looks a lot better than it is. Where we bought 2 samples because I thought there was something wrong with the first one, and then somebody gave us another one, and they're all as bad as each other. Well, it looks like these are about the same. I'm going to spray that RF gain control, which isn't good. Let's see where we are with the squelch. So minimum squelch. .7 microvolts. Better than 10, isn't it? And maximum, because it never opened before. It still never opens. I'll just tell you what maximum squelch is there. No, it up to about 8 you've got squelch. I'll just do something different, put an even higher signal on the signal generator. It's not far off. I wonder if I put my walkie-talkie on, obviously it's going to be a whacking signal, isn't it? That's even that proximity isn't enough. So it's still a never opens. It is non-adjustable. The other one we had has a noise squelch. This doesn't have that option fitted. So it's 2779125 definitely. And the meter wasn't working, but I think we've got it working. The last one we looked at, the meter was lazy to say the least, but at least it's working on this. So let's just turn the squelch down. I'm going to put S9 on. Now you see we can calibrate S9 on this set, but we couldn't on the other. VR2, preset 2 is the S meter. That's set up perfectly, so we couldn't get that to set up on the other radio. I'm just going to go through these again, off camera. Yes, it's not going to get any better performance out of that. So I've managed to get an Allen key to go in there, and with the heat gun and that, we've managed to get it to move. So just see whether we can get more than 2.9 watts out of it. There are a couple of filter trimmers underneath. I'll put the spectrum analyzer on for that. Oh, here we go again. Just that one we haven't got to move. This battery operated heat gun came from Lidl. No, I can't move that. I'm not going to go further. I've put enough heat on, I feel, and let's have a look at those trimmers underneath. So I've got the spectrum analyzer on. I'll keep trying to show you that, but I also realise I've got glare on the screen. So if I switch to that camera, I don't think you're going to see it. No, it's not going to happen. Oh, I could take all the lights off, I suppose, and not see what I'm doing. So I have that loosely coupled in the vicinity of. And look at the second harmonic, so 27.7 times 2 is 55-ish. Frequency 55 megs. So too, I'll put the power meter on the inset picture, and then at least you'll see some kind of alteration. That was at peak, and it's fine on the spectrum analyzer too. And that's at minimum interference, and we're still at 3 watts. So that's that. Turn the spectrum analyzer off. So, as I said on the previous one of these, that probably reads 4.5 watts on a hobby meter, and what we now need to do is go into transmit and set the power meter. I want it to be, if possible, in the centre of the red zone, which is there. Good. See where we are on the other channels. Channel 40, 2.9 watts. Channel 1, 2.9 watts. Channel 20, 3 watts. So it's really well balanced. 2.9 watts, 2.9 watts, 3 watts. Low power. Is 280 milliwatts. Full power current consumption 1.333, just the same. There's no method for that, but if you had a VCO problem, you would simply look up the data sheet on the MC145109 and see which the lock detector pin is, and then you'd monitor that lock detector pin and make sure it was in lock equally between channel 1 and 40 with the coil there. That looks like the VCO coil. What more can one say? Apart from as disappointing as the previous one. I think these are wonderful sets to own. It's a real piece of history, made in the UK, really good quality printed circuit board, plated through, and good quality components. But the fact it does 4 watts on our selective test set is not the case, and as I say, it hasn't been with the previous one we've seen, and the receiver is no better than a Cobra. So that's disappointing when you compare it with something like a Binatone 5-star. It's a great set to have, but they do fetch good money when, you know, the best, as far as I'm concerned, the best set you can possibly buy is the Binatone 5-star. So there you go. But then if we compare with new sets, well, this isn't any less of a performer than a lot of new sets which are out of the box at 2.7 watts, and a lot of them won't go much further. So there we go. It is, to me it's disappointing, but we're going to do it on the air test. We did before, so we've changed the way we do things between now and when I did the last one in 2017, so I can't look back at what the figures were other than what I was discussing. I don't think we were doing SINAD then, or I wasn't writing it down anyway. So we've done, just recap on this, transmit meter, receive meter, just need to do the deviation. Just check it on this test set. Wallow, it's 3.2 on this test set. So we'll see what it is. And then how that speaker mutes between transmit and receive is going to be the next thing. Wallow, it is 3.2, so there we are. Wallow, wallow, wallow. Looks like the Marconi test set's deviation meter is working properly today. So we'll go back onto the Marconi test set. Wallow. There we go. Yes, it's where we want it to be. Does it sound any good? Testing 1 2, testing 1 2 3 4 5. sounds noisy, to be honest. Anyway, I'll see what Mr. Chippie says. We're going to put some lids on. It's a bit, there's a word precarious with it, being this kind of chassis. I'll turn the power off, I think. It is kind of flimsy. You'll see a massive difference in that. Let's get the light such. With me having gone over this with the isopropyl alcohol, having removed those labels which were affecting it with the German cleaner we have. Oh, I don't need to solder those. That's one good point. On the other one, the sticky pads had failed, which adhere this to the case. It's on sticky pads, but they haven't failed on this one. I'm going to put some screws in for now, just for stability. I'll tell you something, what we will do, what can we actually hear down to on the signal generator? That's another interesting thing to do. Yeah, the switch is a bit iffy in that socket, which is why somebody's bypassed it. At least now the lid's on, we're not getting feedback. What I wanted to do was just put the attenuator on, and then you can see where I am. What can we actually hear down to? It's all right saying for so many dB SINAD, but what can we hear down to? We can hear down to about 0.4 microvolts. So put a couple of screws in the lid. I think we'll put all the screws in because I think this is part of the electrical stability issue. These aren't the screening cans that you'd find on most Far Eastern sets. But don't go rushing out buying one of these thinking you're going to get wonderful DX on it, because you're not. The great thing to have on in your collection, don't get me wrong. Right, plug it into the usual roof aerial. We're going to have to look into that extension speaker socket. That is a problem. But we're not getting feedback anymore. One and a Roger. So there we have it. The second Mercury EMS Mercury 1040 that we've done, and sadly just as disappointing. Thanks for watching.